It's another math day here with teacher Jenny. Join me for another topic, and this time we're talking about limits at infinity using horizontal asymptote. We will now start with our limit of x cubed minus 4x squared over x to the power of 4 minus x cubed plus x squared plus 2x plus 1 as your x approaches positive infinity. So right from here, we can actually make use of the horizontal asymptote. There are three cases for the horizontal asymptote. Case 1, in which once we have ax to the power of n over bx to the power of m, if your n or the exponent at the top or the numerator part is less than that of the denominator part, automatic our y value here as the asymptote, the horizontal asymptote, will be as 0. Another case here is once you have ax to the power of n over bx to the power of m, wherein our n is equal to an m, we have here a y value as the asymptote as a over b. So we're getting our numerical coefficient at the top and at the bottom. For case 3, on the horizontal asymptote, we have ax to the power of n over abx to the power of m, wherein our n is greater than m. We don't have an asymptote here, so literally our y here do not exist. But in our limit, we do not refer to do not exist only there, but it could either be a positive infinity, negative infinity, or you can have a d and e in there. So that is why once you have that case, you are going to further simplify the highest exponent term so that you can get your final answer. So let's start off with this example. For this example, if you try to look at the numerator, you get the term which got the highest exponent on x. This time we have our x cubed, so we will be getting that one. And then at the bottom part, we also get the highest exponent variable or term in there. So we have our x to the power of 4. And then once we apply our limit, as x approaches positive infinity, our limit here based on the cases, we have that one as a 0 because our 3 is less than 4. So that is how you get your limit as your x approaches an infinity. So let's now go for another example. So this time we have here the limit of 4x to the power of 4 minus 4x to the power of 5 over x cubed plus 3x squared plus 2x to the power of 5 minus x plus 25 as your x approaches negative infinity. At the top, we are locating our highest exponent variable. We have that entire negative 4x to the power of 5. At the bottom part, we have this one, so we have it as 2x to the power of 5. And then we get our limit as x approaches negative infinity. So since our exponents are equal or the same, automatic will be getting the numerical coefficient on your term. So we have negative 4 over 2, or this is simply equal to negative 2. So let us now go for another example. This time we have limit of x cubed plus 2x squared over x squared plus x plus 1 as your x approaches positive infinity. And comparing the exponents here, we have this one as the highest exponent. We have x cubed. At the bottom part, we have this. We have x squared. So applying the limit there as your x approaches positive infinity. And then simplifying this part, we have that one as a limit of an x as x approaches positive infinity. Plugging in positive infinity, that is equal to a positive infinity. So that is now finding the limit at infinity using a horizontal asymptote. Once again, this is your teacher Jenny saying, Practice and practice, and someday you'll get perfect.